Okay, we're back. Start the clock, and here we go. Paragraph 4. The author explains that this guy didn't know about orbital inclination. Glaciation occurs when the orbital inclination has entered a new cycle. The Earth always travels through clouds of debris after moving out of the plane by a few degrees. Don't like that word always. The amount of solar energy reaching the Earth's surface causes the changes of temperature. Okay. What does he explain? These and other problems with the Milankovitch cycle has led some researchers to seek alternative explanations for the arrival of ice ages. In the 90s, it was discovered that the orbital inclination of the Earth could be responsible for climate change. He did not know about it. Doesn't say that, does it? If we imagine a flat plane, blah blah blah. Two scientists have proposed that it is this orbital inclination which is ultimately responsible for the periods of glaciation. Doesn't talk about entering a new cycle though. They argue that because of the oscillation, the Earth periodically travels through clouds of debris in the form of dust and meteoroids. Such debris could reduce the amount of solar energy reaching the surface, thus plunging it into regular cold periods. Earth always travels through clouds of debris? I don't think so. Which must mean it's you. The amount of solar energy causes the changes of temperature. I don't remember it saying that either. Okay, the amount of solar energy reaching the surface, plunges it into cold periods, changes the temperature. That seems to be the one. Woohoo! Next one. What problem in the Milankovitch theory was mentioned as being explained by the Muller and McDonald theory? So what problem with that was explained by that? So it's going to be introduced, and we've got the alternative, this theory. Okay, this is Muller and McDonald. So the advantage of this theory is that it's not confronted with several of the problems associated with the Milankovitch theory. In particular, the new theory fits well with the analysis of ocean sediments taken from 8 locations around the world. Okay, oceans. This analysis yielded data showing the peak period of around corresponds to the period, blah blah blah, takes it through 8. Okay. The climate records obtained by studying microfossil deposits. Microfossil deposits? Remember seeing microfossils anywhere? Why would they just make that up? Anyway, hang on, we'll come back to that. The irregularities of the Earth movements through the orbital inclination not follow any pattern. That doesn't say that there. The Earth's spin wobbling in relation to the Earth's oscillating inclination. The Earth's spin, it doesn't say that. A peak in the ice age occurs at intervals. And it doesn't say that. It talks about fits well with ocean sediments. I mean, that's tenuous. Let's read on. No, that doesn't talk about. That's a problem with it. Ocean sediments, the climate records, microfossil deposits. Well, I'm going to assume that sediments here are about fossil deposits. Sediments is like the dirt at the bottom of the ocean. I'm going to guess at that, but it seems... fossil record. Tenuous. This is not easy. Persuaded is closest in meaning to... That seems very easy. Convinced, discouraged, affected, challenged. Well, I'd better check. They're not yet persuaded by the hypothesis. That was too easy. What problem is associated with the Muller and McDonald theory? That's the last paragraph, isn't it? Many researchers are not persuaded. The main problem is the amount of dust that falls to the ground. This is small, not enough to produce climate changes. Volcanoes produce more. Okay, the amount of debris released from volcanoes, no. The amount of ash and space, the amount of ash from volcanoes and space dust is too small, no. The amount of dust entering the atmosphere is less than the amount of ash. That seems to be right. The byproducts caused by... It's that one. We got 5 minutes. 2 more questions. Okay, we got to put this sentence in here somewhere. So we have to click on a square. Okay. When the Earth is at its furthest from the Sun, less sunlight reaches the surface. Many different factors, blah blah blah. The 3 most prominent, well, no, that doesn't... Why would that go there? It doesn't go there. So this varies over time for 3 main reasons. First, the planet wobbles as it spins, blah blah blah. Nothing about spinning. Furthermore, the Earth tilts, blah blah blah. Nothing about tilting. Finally, the orbit is elliptical and the length changes over a period. The Earth is its furthest. Length period change. Boom. That's right. And final question. Alright. Select the appropriate phrases from the answer, match them to the category. 2 of the answers will not be used. So we've got 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Drag your answer choices to the space where they belong. To review the passage, click on View Text. Okay. So let's see, flaws in the Milankovitch cycle, flaws in the Muller-McDonald theory. I only remember one here, wasn't that the volcano? Relatively mild effect of volcanoes on the climate, yeah. That seems definitely to go there. Wasn't there a couple of flaws with that? Something about ocean sediment? Ocean sediment. Da 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 da. What else do I remember about that? Let's see. Temperature rise, I don't know. The irregularities of the Earth during its orbit around the Sun. I'm not sure about that. The inconsistency between periods of sunlight and glaciation. Yeah, I remember that. The inconsistency between sunlight and glaciation. No, that seems weird. The orbital inclination of Earth through clouds. 2 minutes. Okay. Small amount of interstellar debris. Okay, that's that one. The lack of physical evidence in support of the effects of the inclination hypothesis. Data of climate records not coinciding with predicted intervals. Yeah, that seems to be that one, doesn't it? Temperature rises occurring before the increase of sunlight. That sounds like nonsense. The irregularities of the Earth's movement, the inconsistency between periods of sunlight, the orbital inclination. Well, this is the only one that can go with that, I think. So they must be there. Temperature rises occurring before the increase of sunlight. Irregularities of the Earth during its orbit. Hang on. Inconsistency between periods of sunlight, the orbital inclination. Orbital inclination, I remember that. Temperature rises, irregularities. The flaws. Why is that a flaw? The irregularities. Or I'll try that one. And got no feedback. 2, 3, 4. Hello. Have I got them all wrong? Is that right? Feedback. I've got 6 right. Oh bugger, one's wrong. 45 seconds. The match between solation and glaciation were not exact. Ah, microfossils, there it is. Also, so the installation period predicts peaks of sunlight at 95 and 125,000 years. Okay, 10 seconds. That one. Da. Still got 6 right. Bugger. Alright.